Hello, welcome to your first Algebra 1 video notes. This is Unit 2, Lesson 2. Today we are going to be talking about inverse operations with multiplication and division. So in your notebook right now, what you are going to write down is the title. You need to draw in your Cornell notes and then draw in on the side. And you're going to write Unit 2, Lesson 2, one-step equations, multiplication and division. If you still need time to write, pause the video right now, finish writing your title, and then unpause. But I'm going to keep going because if you ever need to pause and rewind, you can do that in a video. So our first notes are going to be multiplication and division as inverse operations. In class, we talked about how addition is the opposite of subtraction. Addition undoes subtraction. And then the other way around too, where subtraction will undo, subtraction undoes addition. So we talked about this in class. This is review. This is your prior knowledge. Now let's talk about multiplication and division. I'm going to switch over to this. Okay, multiplication and division are opposites. To undo multiplication, we divide. To undo division, we multiply. So there are some key vocabulary words that we are going to talk about today. We're going to use the word inverse operation, which I should write down as vocab. Come on, vocab. Vocab. Oh, goodness. You could write the vocab under the big ideas section of your notes if you want, because it is a big idea. Vocabulary is a big idea. Vocab. Inverse operation. And I'm about to say something and not write it down, so you have to listen carefully. Inverse operations are opposite operations. Operations are adding, subtracting, multiplying, or dividing. Write the vocab under the big ideas section of your notes if you want, because it is a big idea. Vocabulary is a big idea. Vocab. Inverse operation. And I'm about to say something and not write it down, so you have to listen carefully. Inverse operations are opposite operations. Operations are adding, subtracting, multiplying, or dividing. And the whole point of this is to make sure that equations are balanced. So we are going to talk about the word equations. Equations, algebraic equations, are going to be math expressions, two math expressions that are equal, and they're represented by an equal sign. So let's take a look at our first example. There's a lot of stuff. If you need to pause the video and to rewind, to write down a few things that I said but did not write down, you do that now. Otherwise, title the next part Example 1, and you're going to write 4x equals 20. So there's a couple ways that we're going to do this. We're going to do this with our tape diagram. Tape diagram. And we are going to do this with algebraic method. Eventually, you will be able to choose, and most of you should be choosing algebraic method by the end of next week. But if you still want to use tape diagrams to model, when we model problems, then that's when we're going to use tape diagrams. So we have 4x is equal to 20. How this works is both the left-hand side and the right-hand side are equal. That means that this is the left-hand side tape. It has to be the same length as the right-hand side. I know one of them is on the top and one of them is on the bottom, but bear with me. So this left-hand side here, this says 4 times x. So there are 4 x's in this one piece of tape. X, x, and x, and x. Let's zoom in. In this tape diagram, there are 4 x's. So altogether, this is going to equal to 4x. You can either do x plus x plus x plus x, or you can do 4 times x, and you'll get 4x. Now, this has to equal the same length of this tape diagram, and this is going to be 20. So how do I figure out what each of these segments are? I'm going to divide, keyword, divide by 4. So I have 20 in this entire piece of tape, and just like this tape, I'm going to divide it into 4 parts. So if I divide 4 parts into 20 parts, I'm going to end up getting 5 here. 5, 5, 5, 5. Now look at this tape diagram. If x, this is x, and this is x. So what does x have to equal? X must equal 5. So that's the tape diagram version. But what was the key thing that I did? I divided. This says 4 times x is equal to 20. So I divided. I divided 20 divided by 4. And I got 5. But I did that with the tape diagram. So this side is, this side is this tape diagram here, and then this side is this tape diagram here. So this is equal to 20, this is equal to 4x, and together they equal to 5x. Okay, let's do this algebraically. I'm gonna zoom out. If you need to pause and write that down, pause and write that down. Okay, algebraically, 4 times x is equal to 20. The opposite of multiply is to divide. Fractions are division. You may have learned that in your academe class, but fractions are also division. So we're going to divide by 4. And what we do to one side of the equation, we have to do to the other side of the equation. That is the golden rule of algebra. If you didn't have that written down, go back and listen to that again. What we do to one side of the equation, we have to do to the other side of the equation. That's the golden rule of algebra. Okay, so now I think here I've divided by 4. So what is 4x? Well, I know 4 divided by 4. Well, I know 4 divided by 4 is 1. So watch how I do this. I draw a big 1 here. That's the property of 1. And I'm left with 1x. Some of you will write 1x like this, and some of you will just write x. Then I do 20 divided by 4. If you need to punch this in your calculator, that's okay. Punch in 20 divided by 4. You're going to get 5. We came up with the same answer. X is equal to 5 and x is equal to 5. Let's try a division problem. Example 2, division. Did you need to pause? If you need to pause and catch up, pause now and catch up. I'll be here. Okay, Division. I'm also going to do a tape diagram. Tape algebraic. For tape diagram, how this works is I'm also going to draw in one piece of tape, and then I'm going to draw another piece of tape, and they're equal. This blue 1/5 times x is equal to 2. So these two should be the same. Now, let's break this down, this 1/5 times x. This whole bar, tape, we're talking about tape here. This whole piece of tape is x. Ta-da, this is all x. Now, 1/5 of this piece of tape, that's what this is saying, 1/5 of this piece of tape is equal to 2. So 1, 2, 3, 4. So I have 5 parts here. I tried to make them equal. Here, want me to make them more equal? I'll make them more equal. 1, 2, 3, 4. Okay, there are 5 parts here. 1/5, 1/5, 1/5, 1/5. So 1/5 of this is 1/5, because there is 5 of these, has to equal to 2. Okay, so this is going to equal to 2. So what is x going to equal? Well, you fill in a 2 for every 1/5. So if this is 1/5, this is 2. 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 So what is this value of x? Because if 1/5 is equal to 2, how many of these 2's are here? Well, 2 times 5. Ooh, 5. I multiplied here. I multiplied to undo division. I multiplied to undo division. So in my tape diagram, each one of these was equal to 2. That's what this said. But we needed 5 of these to equal to x. And so this entire length here is also equal to x. So what does x equal? 10. Let's try this algebraically. Okay, algebraically we have 1/5 x equals 2. X also has an invisible 1 underneath it, which is good. Now, how do we isolate x? If this is x divided by 5 is equal to 2, if this is x divided by 5 is equal to 2, I need to multiply by 5 on both sides. So I'm going to take this, I'm going to multiply by 5 over 1 on the left, and I'm going to multiply by 5 over 1 on the right. That's the golden rule of algebra. So now I have 5x over 5 is equal to 10 over 1. So let me simplify. 5x over 5, that's equal to 1x, and 10 over 1 is equal to 10. So again, my answer is x is equal to 10. Pause, go back. If you need to write notes to yourself, like, oh, be careful, add a 1. Oh, what? How about write in a 1? Write 1 in denominator. What I'm doing here is I'm annotating denominator. And you do this in your head, but sometimes it's helpful when you take notes with videos that you do this on your paper as well. And by sometimes, I mean always. You can also put this in your big ideas section. So now we should take a look at what your notes should look like.